welcome back to my video. My name is Asima Simanjuntak. My ID number 4193111045. I'm a college student from Mathematics Education Study Program 2019 at State University of Medan. Now, I want to explain about the Babylonian mathematics development. Babylonian mathematics is mathematics invented in Mesopotamia 2500 years BC in the Babylonian civilization. Babylonian mathematics refers to all mathematics developed by the Mesopotamians in what is now Iraq. The Babylonians were the first to write number from left to right. This is evidenced by the number of tablets found written from left to right. The Babylonian mathematical system is sexagesimal, or a number based on 60. The number of 60 has many divisors, namely 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30, which makes calculations easier. Now, I will explain about the 7th point about the Babylonian mathematics development. First, the emergence of Babylonian mathematics is 2500 years BC. The Pharaoh period is the period during which the Sumerian civilization was used by the Babylonian for phonetic writing. 2340 BC, the Akkadian dynasty writes mathematics in Akkadian and further develops the number system. In addition, this nation is the inventor of the abacus. 2100 BC, referenced the re-establishment of our Sumerian city as a capital now occupied by Akkadians, as well as the high point of its dominancy under King Sulys. 1800 years BC, Old Babylon or Obi is the supremacy of the northern city of Lower Babylon or Akkadia and has the most advanced mathematical texts. Then 2. Development of mathematics in ancient Babylon. Babylonian mathematics refers to all mathematics developed by the Mesopotamians, or now Iraq, from the beginning of Sumer to the beginning of the Hellenistic civilization. Named Babylonian mathematics because of the Babylonian region's primary role as a place to study. At this time of the Hellenistic civilization, Babylonian mathematics combined with Greek and Egyptian mathematics to give rise to Greek mathematics. Then under the Islamic Caliphate, Mesopotamia, especially Baghdad, once again became an important center for the study of Islamic mathematics. The Babylonian plate 7289 BC gives an approximation to 2, which is accurate to 5 decimal place. Next 3. The Babylonian number system. The Babylonian number writing system was known as cuneiform, from the word sunesis, which means slice of or split, and the word forma, which means form. Babylonian writing and numerals are often referred to as cuneiform because they are shaped like nails. The Babylonians wrote cuneiform using an elongated triangular space stick by pressing it against a wet clay plate to produce a temperate triangular depression resembling a nail. Unlike those of the Egyptians, Greeks, and Romans, the Babylonian numerals use a correct place value system, in which the number written in the left column represents the larger values. In the form of numbers used, the Babylonians inherited the idea from the Sumerians, namely the sexagesimal number system, or base 60. Due to the Babylonian prominence in astronomy, the 60-base system of calculation is still in use today. It's provided by the derivation of the numbers 60 seconds for 1 minute and 60 minutes for 1 hour, The reason why the number 60 is used is because this number is the smallest number that can be divided by the first 6 digits, namely 1, 2, 3, 4, 5, and 6. Another reason is that the number system most widely used by humans today is the decimal system, which is a system based on 10. The Babylonians wrote cuneiform using an elongated triangular shaped stick. By pressing it against a wet clay slab to produce a point hollow like a nail. The following is an example of writing symbol for the Babylonian numeration system, namely like this picture. The Babylonians used 1 to represent 1, 2 to represent 2, 3 to 3, and so on up to 9. However, they tend to organize the symbol into neat stacks. Once they got the tens, there are too many symbols, so they turn to make different symbols. And next, 4. Number theory of the Babylonians. In the age of the Hellenistic civilization, Babylonian mathematics combined with Greek and Egyptian mathematics to give rise to Greek mathematics. Then under the Islamic Caliphate, Mesopotamia, especially Baghdad, again became an important center for the study of Islamic mathematics. Contrary to the security of search on Egyptian mathematics, knowledge of Babylonian mathematics was derived from more than 400 clay tablets excavated since the 1850s. They developed a complex system of meteorology as early as 3000 BC. From about 2500 BC onwards, the earliest stage of the Babylonian number system also referred to this period. Most of the known clay tablets date from 1800 to 1600 BC and cover topics of fractions, algebra, quadratic and cubic equation, and the calculation of regular numbers, multiplication inverses, and twin primes. The slab also includes multiplication tables and methods for solving linear equation and a quadratic equation. Babylon's mathematics was rising using the sexagesimal-based 60 number system. From this derived the use of the numbers 60 seconds for a minute, 60 minutes for an hour, and to 360, 60.6 degrees for a circle, as well as the use of second and minute and a circular arch which represents fractions of degrees. Also, unlike the Egyptians, Greeks, and Romans, the Babylonians had a true place value system, where the numbers written in the left column represent the larger value, as in the decimal system. Babylonian numeral system, the first people who recognized the number 0 were Babylon. And next 5. Advantage and disadvantage of the Babylonian number system. First, advantage of the Babylonian number system. There are 1. Recognized building forms. And 2. Determination of the value of the square root. 3. Has demonstrated the Pythagorean theory. Then 4. Measure and area or area and volume. B. Disadvantage of the Babylonian number system. There are don't know 0, then not familiar with commands to make decimal number, then don't know the negative sign, then the addition, subtraction, multiplication, and division are still unclear. Okay, next we go to the number 6. Invention relating to Babylonian mathematics. There are first, field geometry. The geometry was used by the Babylonians from 2000 to 1600 BC. They calculate the circumference of a circle using 3 times the diameter. The area of the circle is just 1/12 of the square of the circumference with 3.14. The volume of an upright cylinder is calculated by multiplying the area of the base by the height. And next to field of algebra. Around 2000 years BC, the development of algebra is not only able to solve the quadratic equation, but also discuss solving third and fourth power equation. It can be seen that the tree is a relic in the form of tablets, whose contents are in the form of tablets of square and cubes of number 1 to 30 and combination of n3 and n2. Next, sexagesimal numbers or base 60. Babylonian mathematics was written using the sexagesimal number system base 60 because of its superiority in the field of astronomy. The 60-base calculation system still exists today, namely by writing the use of the number 60 seconds for the 1 minute and 60 minutes for 1 hour. The weakness of this system is that there is no zero symbol. The symbol 1 and 60 are the same. In this case, the spacebar will also not be able to help explain whether the symbol is 1 or 60. Next, Plimpton 322. This system first appeared around 3100 BC, known as the positional numeral system, where the value of a particular digit depends on the number itself and its position in the number. The purpose of the Babylonian tablet containing the analytical table known as Plimpton 322 is a collection of Plimpton at Columbia University with catalog number 322. Next 7. Babylonian mathematical relics. The cuneiform script was used in the manufacture of the Babylonian letters. The plates are written while still wet and then dried of burner. There were blackbirds found, namely 1. Yale UBC 7289 bird. The Yale UBC bird is a bird in which a diagram is drawn in the shape of a rectangle measuring 30. The Yale manuscript 200 BC contains n3 and 2 tables for solving equation, including cubic equation that lead to simulation equation leading to quadratic equation. Next, B. Plimpton 322. Plimpton is a bird number 322, which is the result of processing ancient Mesopotamian manuscripts written by G.A. Plimpton containing mathematical problems. The Plimpton 322 manuscript is in the form of a table consisting of 4 columns and 50 rows containing Pythagoras triple numbers. Next, the Susa board. This board will show how to calculate the radius of a circle, trough, and equilateral triangle. In the Susa board, there is a rectangle ABC with the center of the circle at the point O, and there is a line AD connecting point A with line BC. Okay, I think that's all from me that I can explain on the topics of Babylonian mathematics development. If I have a mistake, I apologize. I hope I will be better in the next chapter. If there are a critique or suggestion, you can write them in the comment column. Hopefully, this explanation video is useful for you. Thank you for watching and see you next video.